Hello, we are going to do 8 and 4, lesson 6, solutions of a linear equation. So we're going to basically continue what we've been working on, solving linear equations. Today specifically, we're going to focus on the concept of adding in distribution. We've done this before, and you hit this last year in 7th grade as well, but we're going to do a lot of these, again, solutions to linear equations. Every single one of them will involve distribution, and I'm going to go through and remind you of some of the keys to distribution so that you won't be making any mistakes. Let's go and let's get set up here with our sketch pad. Taking a little bit longer than normal, but here it is. Okay, so let's review. Right now, this is just review time. And we're going to remind ourselves how it is that we do distribution. And these are going to be, this is 5 expressions here, and we're going to solve, or we're going to simplify each one of these through distribution. So the first key to realize when we're doing distribution is you're going to, any number on the outside, if it's multiplied by two or more terms on the inside of parentheses, then we use distribution. So we use it with multiplication on the outside of parentheses. Well, it's multiplication of a parentheses, or a parenthesized expression. So what does that mean? So we have a number outside, and it is multiplied by 2 or more terms inside the parentheses. Okay, so our terms are groups of symbols that are separated. Terms, remember, are separated by additions and subtraction signs. So here we have one term. This is term 1. This is our term 1, and this is our term 2, because they're separated by an addition sign. You could also have them separated by subtraction signs, as we do in problem C. So what we do, we have a number on the outside. I like to draw arrows and say we're going to multiply this term on the outside by the first term inside, and then the second term on the inside. We're going to do this 5 times. Let's watch how this is done. So we say that's equal to, and if you know how to do distribution, just go to the next slide. This is just review time. And so that equals 2x, because 2 times x is 2x. And then we take this addition sign here and we put it here. And then we take our 2 times our 4. So we get 2x plus 8. Okay. So in this case, let's look at B. On the outside, we have negative 1/3. And on the inside, we have 9y plus 12. So negative 1/3 times 9y is negative 3y. We take our plus, and negative 1/3 times 12 is negative 4. So our answer, if we simplify, is equal to negative 3y minus 4, right? Because if we add a negative 4, that's the same thing as subtracting 4. We getting the hang of this? Okay. Or are we remembering that? Let's move on to D. C is going to be a little trickier. So let's start with D. And we'll see that we actually, inside here, we have 3 terms, because we have an addition sign here and an addition sign here. So we have 3 terms. So let's draw our arrow. And we get 4x plus, that's our plus 4y plus 40. See how this works? Remember how this works? Now, and let's do e before we do c even. So here we got negative a half, or negative 0.5. Negative 0.5 times 4x is equal to negative 2x, plus negative 0.5 times 7 is a negative 3.5. So our answer is negative 2x minus 3.5 after we simplify. Okay, our last problem is this one. Now this one can kind of throw you for a loop, but this is one of the easier problems if you just remember that this negative in front is kind of like a net. You can kind of imagine this to be a -1, and then everything becomes really clear. So some people say, hey, if there's a negative out front, just flip the signs, and then you get this, right? If this is a negative out front, you just flip the signs. That's a rule that some people learn. So positive 4x becomes negative 4x, and negative 6 becomes positive 6. But the reason that that rule works is because this is really a -1 distributing. So let's do that this way, and we'll see that we come out with the same answer. -1 times 4x is negative 4x minus -1 times 6 is negative 6. And a negative becomes a positive. So we get negative 4x plus 6. So this is all just kind of a quick review of distribution and some things and some tricks that you need to know, right? Negatives, flips kind of change signs. And the reason is because what we just learned here, that's like a -1. -1 will ultimately flip these signs on the inside. Sometimes we have 3 terms. We have to do 3 multiplications in that case. I always like to draw my arrows. Arrows are helpful. Okay, let's move on. Hopefully this distribution comes back to you. Very much a building block, distribution. So distribution is a thing that we use a lot. Now what we're going, it's very common. You're going to use this all the way up through geometry and Algebra 2, pre-calc calculus. It's forever with you in mathematics. Okay, so let's do these problems. These problems rely on the building blocks of distribution and on the solving of equations that we worked on in lesson 5. So let's look through these problems. Now, the first thing that we're going to do in all of these problems really is we're going to distribute. Let's use a different color as we distribute and solve these problems. So here, our distribution over here this is our distribution problem right here. All right, this is we're going to have to do distribution here. We're going to have to do distribution here. 4 minus, we just move this 4 minus down, and we're going to use the solution to this to plug into our equation. And over here, we're just going to do, distribute here and solve. Okay, so let's watch how this works. And then I'm going to give you a problem after this. Okay, so we're just going to move our 4 minus down. And now we do our 3. And we're going to subtract the solution to our distribution problem, right? So we've copied down our 4 minus right here. So now we're going to distribute here. So 3x is 3x. And 3 times -4, 3 or minus, put our minus here, and 3 times 4 is 12. Okay. And now we actually have another little kind of distribution problem right here. Well, let's distribute this side first. Let's just distribute our 7x, move our minus down, and 14. Now we have one more distribution problem, right? Next, this is kind of like a -1 here. Or you can think of it as flipping signs, whichever one you want to do. If we flip signs, we just simply get 4 minus, this was positive, so we'll get, minus 3x. We get plus 12. Okay? If you did it the other way and put your -1 in here, you get -1 times 3x, and that'd be our -3x. move our negative sign down. -1 times 12 would be -12, and we'd have a -12. And so there we get our +12 back. So if you went and did it that way, it'd work out to the same thing. Okay, so 4, now we're going to combine like terms here. So we're going to take our 4 and combine it with our 12, and our -3x has no like terms. So we have -3x plus 16 equals 7x minus 14. And now I'm going to collect my x's on the right and collect my constant terms on the left to keep everything positive, because I can see that if I subtracted 7x from both sides, I'd end up with negatives, and I just like to work with positives where possible. So I'm going to add 3x to both sides. This cancels, and I get 16 equals 10x minus 14. Now I'm going to add 14 to both sides and so I'm collecting my constant terms on the left and my variable terms on my right. So this will cancel, and I get 30 equals 10x, and this is working out nicely. And now I'll use my division property, and I'll get x equals 3. Always a good practice is to check our answer. I'll do this in this color. So let's see if this works out here. So I'm going to plug my x equals 3 back in here and see if I get the same thing as if I plug my x equals 3 back in over here. If I plug x is 3 in here, I get, well, 3 minus 2, 7 times 3 minus 2 is equal to 7 times 1. So that equals 7 on the right. Now the left, I have to get 7. If I get 7, then I've correctly solved my problem. So 4 minus 3 times 3 minus 4. Well, that equals 4 minus 3 times -1. Well, -3 times -1, 4 plus 3, that equals 7. So check, this works. X equals 3 is my answer. Happy cat. Now hopefully, maybe you can try this one on the right if this is all making sense to you. And I'll let you go ahead and do that if you want. Pause and go. Otherwise, I'll just get going and I'll get solving it. So let's do our distribution. A half of 4x is 2x. Take our minus sign down. Half of 10 is 5. 3 times x, 3x minus 15, our negative. There's our negative. Subtract 2x from both sides and add 15. Let's do these at the same time. Watch this. We can add -2x plus 15 to both sides and do our simplification step all at once. Those cancel, add down. Positive 15, -5 is a positive 10. 3x and -2x is x. X equals 10 is our answer. And now I can check. Let me try my check step. A lot of teachers like these check steps. Just take our 10, plug it in for x up here, and let's go. Half times 4 times 10 minus 10 equals 3 times 10 minus 5. Is that true? 3 times 5 equals 15 on my right. My left is 40, or a half of 40 minus 10. 30. Half of 30 is 15. Check. Happy cat. All right, let's move forward. Solutions of a linear equation. So I'm going to let you solve this one. It's your turn. Try. Remember what we do with negatives. Okay, I assume you've paused to have the right answer, but let's our -1, and we get -x plus a -2, which is like a -2. Over here, -2 times x, -2x, minus -2 times 5 minus -10, which becomes a positive 10. X minus 2 equals -2x plus 10. Add 2x to both sides. And I'll add 2 at the same time. And I'll get x equals 12. Who remembered to check their answer? Let's check it in green. Negative 12 plus 2. Does that equal negative 2 times 12 minus 5? Well, let's see. Negative 14, which equals negative 14, equals negative 2 times 7. Well, negative 2 times 7 is negative 14. Check. Happy cat. All right. So it's all about distribution and then about solving equations. This is all about practice. This is really about using the building blocks of solving equations into distribution. And really, a lot of distribution is about getting the positives and negatives straight. Who's made a negative or a positive error so far today? Very common, so don't get down on yourself. Just keep practicing and you'll really get the hang of it. Now, one other thing that is key, and they bring this up in today's lesson, and it's all about having no solutions to a linear equation. So the key is that sometimes there are no solutions to linear equations. Now, we're going to keep coming back to this, but they just want to hit you with this today just a little bit, not focus on it too much, but just to remind you that sometimes you're going to solve equations and you're going to get no answer. You're going to get this weird truth. So watch what happens. I'm going to write an equation or a sentence, a math sentence. And it's going to be a number is equal to a number to two more than a number. Now this should send off some warning bells for some of you. Now watch why that should be true. So is equal to. So we know what is equal to, and that's an equal sign. So this is a math sentence that we can convert into algebra, just like we've been doing. An expression equals an expression. So this means equals a number. We don't know what a number is. So remember, when we say a number, we just mean like an X or a Y. So we're going to use X. And that same number is also X. So a number, X, is equal to 2 more than a number, is equal to X plus 2. That's the conversion. This is our building blocks. This is from earlier lessons in this unit. Now, the problem is just think in English. Just forget about math for a second, and let's just think this through. Is it ever true that a number is equal to 2 more than itself? Is the number 5, could it ever equal 7? A number equal to 2 more than itself. Could 10 ever be equal to 12? Well, the answer is never. So even though I can write this in algebra, there shouldn't be a solution. There should be no solution. And watch how algebra tells us that there should not be a solution. Watch how algebra tells us this is true. It's so cool. So let's try and solve this. X equals X plus 2. So we're going to subtract an X from both sides, right, to try and simplify. And we get 0 equals 2. Well, this is nonsense. This is never true. It is never true that 0 equals 2. Never, ever. So that means if you start with this sentence here and you end with a false, if you end with false, if you end with false statement, then original equation is false and has no solution. Right? So if you go back and looked at all of these other equations that we did earlier, like this one here, we had a solution. If you look at these two equations, they had solutions. But sometimes you'll get no solution. Now watch, there's one other kind of equation where you'll get no solution. And I encourage you to try this one out here. And I'm telling you the answer is no solution. But this is one with distribution. So if we say 2 times x plus 1 equals 3x plus 2 minus x, you're going to get no solution. And watch how this works. 2x plus 2 equals 3x plus 6 minus x. I have to combine my like terms on the right side, and I get 2x plus 2 equals 2x plus 6. I subtract 2x from both sides, and I get 2 equals 6. Well, this is never true. So this equation, original equation has no solutions. So let's summarize. In this case, I can look at the math sentence, the equation, and I can kind of see that it's never going to work. It's never true that a number is equal to 2 more than itself. But sometimes I look at an equation like this one, and I have to solve it or try to solve it before I can see that it has no solutions. So I'll just leave you with that. We're going to come back to that in future lessons, but just remember that sometimes linear equations have no solutions. Now we're going to hit the final piece of our lesson, which is always homework help. Now I want you to try these two equations. Notice there's 2 ways actually to solve equation number 1. You can start, and they have the same answer, of course, but you can start by just using distribution and going about solving, or you can go about using the division property of equality and dividing both sides by 11, which is the same thing as multiplying both sides by 1 over 11. All right, I'll let you go about trying these. Now I want you to pause and try both. Do both of them. And I will solve. Okay, I assume you've paused and tried. Hopefully you have both answers, and let's go about it. I'm going to start with just doing distribution here, and I get 11x plus 44 equals 44. Oh, this is nice. Minus 44 from both sides. 11x equals 0, so x equals 0 because I multiply both sides by 1 over 11, or divide both sides by 11. X is 0. Check. Does 11 times 0 plus 4 equal 44? Does 11 times 4 equal 44? Does 44 equals 44? Check. If you did it the other way, we could have just done this, and here's version number 2. We could have said 11 times x plus 4 equals 44. Divide by 11. divide by 11, cancel, cancel. X plus 4 equals 4, subtract 4, x equals 0. So either way, version A or version B, they both give you x is 0. You should never be able to solve an equation 2 different ways and get 2 different answers. It should always give you the same answer. All right, let's do this side. 2x minus 12 equals 10. And we can just flip our signs, minus x plus 2. For those of you who distributed, you'd end up with negative x minus negative 2, which is equal to negative x plus 2 as well. Combine like terms, we get negative x plus 12. 2x minus 12, add x to both sides. Cancel, cancel. 3x minus 12 equals 12, add 12. 3x equals 0. 0, Mr. Lipscomb equals 24. Divide by 3, x equals 8. Check our answer. 2 times 8 minus 6. Does that equal 10 minus 8 minus 2? Does 2 times 2 equal 10 minus 6? Does 4 equal 4? You betcha. And we have x equals 8. Lay down our happy cats. Happy cat for completing the lesson. Meow. And let's call it a day. Right back at you. Good work. Well, we'll continue on with lesson 7 soon. Happy math.